Here, we have two sets of data. We have the scores recorded before and after a certain period of time. Hence, we call them pre-test scores and post-test scores. These are represented by the second and the third columns. The first column is a representation of the student. Now, we would like to test whether there's a significant difference between the mean scores of the students during pre-test and post-test. And what we usually do for this kind of situation is to use the paired samples t-test. But before we could use the paired samples t-test or paired t-test, we need to establish the 4 assumptions for it to be used, because if these 4 assumptions will not be met, then we cannot use the paired samples t-test. We might be able to use a separate or a different form of test, which is a non-parametric equivalent of paired t-test. Before we start, let's not forget that you could always change your identification, specifically for the label of your data in the variable view. Take note that for the first row, this is our first column on our data view. Our second column will be the pretest scores, and of course, its scale measurement. That also includes our post-test scores. For our third column would be on scale measurement. So once we are done with that, we can return here. And again, we can now start determining whether we can use the paired samples t-test here with these 4 assumptions. The first assumption that should be met before we could use the paired samples t-test is that we must have dependent variables, or our dependent variables, or variable in this case, is either in interval or ratio scale. The dependent variable here is actually the scores recorded during pre-test and post-test. And as you can see, they are test scores, and they can fall on a ratio scale because this type of data has true 0. So the first assumption has already been met. The second assumption is that for our independent variables are 2 categorical match pairs. We're talking about the pre-test and post-test. I mean, our independent variable is a time element, and we have here the pre-test and post-test. We have 2 match pairs. When we talk about match pairs, each of the score has a pair. So for example, for student number 1, it has pre-test and post-test score. It should be with the 2 scores, because if only 1 is given, then we are to remove that certain student because it will not help our analysis later. Okay, and that is met already here because we have here 90 pairs of pre-test and post-test scores. Now, for our assumption number 3, there should be no significant outliers in the difference between 2 related groups. If we are going to take the difference between pre-test and post-test, say pre-test minus post-test, our first difference is -4 because that's 21 minus 25. The second difference is 22 minus 19, that's +3. If we are going to compute all differences here, this, or the set of differences, must have no significant outliers. And we have actually established that already on the same set of scores in the previous video. The link is provided below. You might want to review that because that's an important assumption, because before we could use the paired samples t-test. Since we already have the video for that, let's proceed to the 4th assumption. The 4th assumption is that the difference between 2 related groups is approximately normally distributed. This is one of the assumptions that we usually forget and just automatically use paired samples t-test, because if the difference between the 2 groups, talking about the matched pairs, is not normally distributed, then we cannot use the paired samples t-test. We can use the Wilcoxon signed rank test, which is the non-parametric test equivalent of our paired samples t-test. Okay, so we also have a separate video for that. We have already established the approximation to the normal distribution of the differences. Again, the differences is not the pretest and post-test alone. It's the difference between pretest and post-test, which could also be post-test minus pretest. It doesn't matter which of the 2 arrangements. So since all 4 assumptions have already been met, this time we can now use the paired samples t-test to verify whether there's a significant difference between the mean scores of the students during pretest and post-test. And with that, let's start with this hypothesis so that we could, of course, have a guide later in interpreting our result. Let's have our null hypothesis, H sub O, stating, in general form, there is no significant difference between the average scores or mean scores of students in the pretest and post-test, because null hypothesis is a hypothesis of no difference. Of course, our alternative hypothesis is that there is a significant difference between the average or mean scores of students in the pretest and post-test. Usually, if we are teachers applying an intervention, and of course, generally, if we talk about pretest and post-test, it should be given, or it should happen, that there is significant difference, because that should be our goal. If the pretest is done before a certain topic is discussed, and post-test, of course, is done after the topic has been discussed. So the amount of discussion, demonstration, explanation of a topic is already done. So supposedly there should be significant difference. At the same time, if we are applying a certain intervention, we would like to have significant difference, but it might not be true to all. So we are going to examine here if there is significant difference between the pretest and post-test. Of course, our region of rejection, we are to reject our null hypothesis if we could compute the p-value or probability value which is less than 0.05, the default level of significance. And if we ever reject our null hypothesis, of course, the alternative hypothesis might be stating us that the average exam scores in pretest and post-test is significantly different. Take note of the term significantly different. It's not only to be different, because it might be obvious in our data later. We will like to see descriptive as well. But is the difference significant? That's what we'd like to determine here. So let's now start analyzing, or using our SPSS to determine whether there's significant difference. Now, for the test for no significant outliers and normality, we have been using difference, as I mentioned earlier, pretest minus post-test or vice versa. But for analysis of paired sample t-test, we might not need, or we don't need anymore our differences. We can do it like this. Let's click Analyze, proceed to Compare Means, and we have here the paired samples t-test. Again, Analyze, Compare Means, and paired samples t-test. Once you click this, you will have this dialog. Okay, let me put it here. This dialog will require us to place here the match paired variables, and of course we know that to be pretest and post-test. Now there are two ways for you to input it here. You can input pretest first, click, post-test first, click, and they are already paired. If you made incorrect inputs, you can just remove that. Or again, the second way is just simply highlighting both of them and click them at the same time. You will have your paired variables here. Now, you might want to click options, of course, to just observe the confidence interval. The default again is 95%. So let's have with that. And it's already done. You can simply click OK. Once you are done placing your paired variables, you'll be clicking OK, and this is what will happen. Okay, now you will have three tables here, and we are going to talk about them one by one, but of course, we are not going to talk much about them because we are just going to determine whether there's significant difference or not. Look at the first table. These are the descriptive statistics. Look at the mean score of pretest, that's 20.53, and the mean score of the post is 39.7. Now, very obvious, there are differences. Of course, there is more or less positive 19 difference. But is that difference significant? That's what we're trying to determine, because there might be some instances wherein this difference is not significant. Now, your second here table talks about the correlation. Okay, aside from the idea of significant difference, we can also try to determine whether there's a relationship between the scores of the students in the pretest and post-test in the paired samples. But of course, we are not going to discuss this further because this might be covered as well when we talk about correlation later. Now, let's proceed here. This is our paired samples test, and I would like you to proceed here. You see this significance value for two-tailed test. We have 0.00. This is less than 0.05. With this, we can now say that we are to reject our null hypothesis, our hypothesis of no difference, and state now that there is a significant difference between the post-test, pre-test and post-test average scores of our student. That means this difference here is really significant. This is actually our t-value that we usually do manually. Look at our t-table. This is our, using this degrees of freedom, that's n minus 1. 90 minus 1 is 89. So going back to our data here, this set of scores, okay, indicates a very significant difference with the scores in the pre-test and post-test. If you are the one analyzing this and you are the one implementing a certain intervention, you can now say that your intervention is a good one that leads to a significant difference between the scores of the students before and after the implementation. So this is how we analyze our set of data that is applicable for paired samples t-test. But then again, let's not forget the 4 assumptions that should be met, and with that we can apply the paired samples t-test here. See you on the next video.